Hey beautiful people, welcome back to my channel. My name is Busisiwe Dlamini Kharodi, the Cane Path Principal. If you haven't subscribed already onto my channel, may you please click the subscribe button there at the bottom and also click on the notification bell so that every time when I upload a video, you'll be notified. I am back again with another video. So in this video, I want us to discuss calibration or to calibrate. So what is this calibration? So basically it is a process of standardization of your instrument. So what you usually do, basically you are setting up a relationship between the method of measure of the instrument and the known values. And how do we achieve this? You achieve this by using calibrators or substances with a known value. So you know what the concentration of that specific analyte in that substance. So how does an instrument do this? So what will happen is that we will have calibrators which we will get from the supplier. So depending on the instrument, you might find that you have only one calibrator with that known concentration or known value. And then what the instrument will do in the case whereby you only have one calibrator, the instrument is going to do dilutions, different dilutions, so that at the end of the day, it can be able to plot the graph, that graph that we call a calibration curve. Or you might find that with other instruments or other analytes, you find that now you get let's say 5 bottles of calibrators. So all those bottles, they will have their known concentration as well as their depending on what method does that instrument use, if it's absorption, if it's light. So it will have the known values. And then if the instrument will just run them and then plot a graph using those ones. So now I want to make an example with the one whereby you got 1. So let's say with this one, the instrument or the calibrator for that analyte that you have, it's only 1 bottle. And this standard, we can also call a calibrator standard. It has 20 grams per liter as concentration. But what that calibrator will also have the absorption value or the relative light units depending on the method. So if this instrument is a spectrophotometer, so it means it measures absorption. So it also give you an absorption value. So let's say the absorption here value for this standard is 1,62. So now in this case, what the instrument can do, it will do dilutions. So let's say it does a 1:2 dilution and a 1:4, and probably depending maybe a 1:10 and so on, depending on how it has been set up. Then let's say you get values for those dilutions. So you had 20 grams per deciliter, and then another value should be 15 grams per liter. Then you also have 10 grams per liter, and then also 5 grams per liter, for example. And then, like I said, after you have made those dilutions, after the instrument has made its dilutions, and then there will be this concentration based on the dilutions, because if you do a dilution, a 1:2 dilution of 20, what you're gonna get 10, because it's the half of it. And then what it'll do when you put it into the instrument and then it measures, it's gonna give you absorption. So let's say the absorption for this 15 grams per liter will be 0,071, and then for this one it's going to be, now this one is 0,071, and then for the 15 it's 0,119, for the 5 grams per liter, and then let's say it's 0,025. Then what would happen is that the instrument, it's gonna take these values and plot a calibration graph. And then on your calibration graph, on your x-axis, it's going to be the concentration of the analyte, and then on the y-axis is going to be the absorption. Then the instrument is just going to join the points. Say 5, 10, 15, 20. See here, it's 0, 0.025, which is the smallest, and then we can have 0.071, 0.117, 0.162. Then what the instrument will do, will just join the points and then it draws a graph. So once we have the graph like this, it means the lowest that this instrument can be able to measure is 5 grams per liter, and then the highest that these instruments can be able to measure is 20 grams per liter. So that's why if in the patient sample the analyte concentration is it's 4 or 3, it won't give you a value, because outside number 5 it means the curve is no longer linear. The same as above 20 will mean the curve is no longer linear, so it will give you a less than 5. And then if you get a value of 30, it will just say greater than 20 grams per liter, because that's what you were doing. These are only the points that will be acceptable, or the result within this linear graph will be the ones that will be acceptable, because we can be able to trust them. Because another thing with calibration, basically you are determining the accuracy of the instrument as well when you calibrate. So this is what the instrument usually would do. You're gonna have those calibrators, or it will do its dilutions depending if it had only 1 standard or 4 standards. And then from those 4 standards, they will have the concentration as well as the absorption value for all of them. And then when they run in the instrument will just plot a graph. But then for exam purposes, because this usually it's done automatically by the instrument. So for you just load the calibrator and request the calibration, and then the instrument will do the rest. But it can happen that in an exam you can be asked, how would you prepare a calibration curve, or how would you do a calibration curve, and they give you a standard. So in this case they say your standard has a concentration of 100 grams per liter, and then the absorption value of this is 0.7, and then they ask you how would you prepare a standard. So what you can do, what you can say is that you will start by doing dilutions, because you can't have make a curve with 1 point, because in this case you only have 1 point. So you will do dilutions, 1 in 2, 1 in 4, 1 in 5, and 1 in 10. So what you're gonna do now, you're just gonna divide this value, because you know if you do a 1 in 2, it means you're decreasing the concentration of the standard 2 times. So it means you can divide by 2. So it means now automatically by the dilutions that you make, you know how much the concentration is supposed to be. So it means for a 1 in 2, the concentration is supposed to be 50, because it's the half of 100 grams. And then for a 1 in 4, which is the quarter, it's going to be grams per liter. For a 1 in 5, it will be 20 grams per liter. And for a 1 in 10, you will get 10 grams per liter. Then when you are done by getting your concentrations, because the absorption value for your standard is also given, which you can do the same, divide the value by the dilutions that you'll be doing, because as the concentration decreases, it means the amount of light that will be absorbed will also be decreased as well. So here it's going to be 0.35, 0.175, 0.14, and 0.07. And then voila, once you have your values, then you can be able to plot your graph as well. With your concentration will always be on the x-axis and your absorption on the y-axis, which is the same. Then you're going to say, let's say it's 20, 40, 60, 80, 100, and then 0.07, 0.14, 0.175, 0.35, 0.7. Then now you join your points as well. Then 25. It's not gonna be straight because you will definitely use a graph paper. Then for 0.1 is 25. Instead it's 10, 20, then 25. Then after 25 it's going to be 50, should be here. And then 100. Then you just join the points. And then it means that will be your calibration graph, that it's linear and you can only accept the results that are within your calibration curve. So basically that's how you would prepare your calibration curve. And if you have a result and then you find that okay, now when you run a sample you get absorption, let's say of 0.35, then when you come to your calibration curve you will see that okay, it means the concentration of this analyte in the sample is 50 grams per liter. So that's how the instrument as well will get the result. So basically that's it that I wanted to share from you. May you please ask as much questions or comment, or if there's anything that you need to add there in the comment section. I'll be glad to be able to interact with you. From me to you, up until next time, bye.